Michael. Yes, daddy. Come here, come. Right. I have seen your books at school there. All the other subjects, very perfect. But mathematics, Michael, very disappointing. Hey, what's the problem? Daddy, I don't even know, daddy. I think maybe, daddy, I inherited that thing from somewhere, daddy. Daddy, how was your performance in maths during your school days, daddy? Michael, watch your tongue, right? I'm not your friend. Okay, let's do it this way. I download Mangeya's videos on YouTube. Then you can watch them. Maybe you can improve. How is that? Great one, daddy. I think that will work. That will work, daddy. Let's do it right away, daddy. Yes, it will work. Mangeya, the mates, ego. Watch out. Okay, so this one is advanced level mathematics. Advanced level mathematics, Cambridge, Zimsec, or whatever higher level, advanced level that you can enjoy. The topic here is a secular measure. Secular measure. I'm dealing with this topic, right? So pay attention, like the video, and subscribe to my video. Let's get started. The details, you can see my details on the screen, and the topic details, everything available there. Right, so the first part that you have to know and understand under this secular measure is the relationship between radians and degrees. What is the relationship between the two, right? So the first thing is you just have to note 180 degrees in radians is actually pi, which means if it's 360, what will it be? It will be 2 pi. Because 360 is 2 times 180, which is 2 times pi. Take note of that. Then, how can you convert a number from degrees to radians or from radians to degrees? Let me start with this one. To convert a number 180 to a number that will be in degrees, right? So you just say divide by 180 here. You divide by 180 on this side. So it will be 1 degree is equals to pi over 180 radians. Like this. Radians, you can write rad. So that's 1 degree. Then what about radians? What about radians to degrees? Radians to degrees, if we can say 180 is equals to pi, then you divide by pi. It means 1 radian here, 1 rad will be equal to 180 over pi. 180 over pi degrees. Take note of that. So what it means from these two solutions, from these two results, is that if you want to convert a number from radians to degrees, you multiply by this one, which is 180 over pi. Then the same rule applies if you want to convert a number from degrees to radians, you multiply by pi over 180. Pi over 180. So multiply by pi over 180. Just as simple as like that. Then next section, let me go on to, these are the questions now. These are the questions. The first question reads, convert the following angles from degrees to radians. Degrees to radians. Remember, from degrees to radians, I said we have to multiply by what? Pi over 180. So pi over 180. Let's start with the first one, which is 45 degrees. So you say 45 times pi over 180. What do you get here? You simplify. 45 into 180 is actually 4. 4 times. So it will be pi over 4 radians. Done. That's the first part. Then second part, part B, 120 degrees to radians, you multiply by pi over 180. Then if you can simplify this one, 0, 0 cancel out, Then 12, 18, you simplify by 6. 6, 2, 6, 3. So it will be 2 over 3 pi radians. Done. Part C, 720. It will be 720 times pi over 180, like this. Then you simplify 0, 0. 18 into 72 is actually 4. So it will be 4 pi radians. Done. Part D, 150 times pi over 180. So it will be 0, 0 cancel out. Then 15 and 18. What can you use? Common factor 3. 3 into 15 is 5. 3 into 18 is 6. So it will be 5 over 6 pi. Then last one, part E, is 240 times pi over 180. This one will cancel out. Then by 6. 6 into 24, 4. 6 into 18 is 3. So it will be 4 pi over 3. Right, next part. Question number 2. This now is from radians to degrees. Radians to degrees. Remember we said you multiply by 180 over pi. Right, the first one, for part A, is 5 pi over 4. So you multiply by 180 over pi. Pi will cancel out. Then 4 into 180. 4 into 18, it's actually 4 remainder 2. 4 into 20 is 5. Then 45 by 5, what do we get? 5, 5, 25, 5 carry 2. 5, 4, 20, plus 2, 22. So it will be 225 degrees. Then part B, 5 pi over 3. You multiply by 180 over pi. The same rule applies. The pi will cancel out. 3 into 18 into 180 is 60. Then 5 by 60, you get 300. That's what you get from your calculator or even mental work. Then next one, 3 pi. 3 pi, that's part C. You multiply by 180 over pi. Pi will cancel out. Then you multiply 3 times 180. What will you get? 3 times 0, 0. 3 times 8, 24. 4 carry 2. It will be 540 degrees. Then D, pi over 6. You multiply by 180 over pi. Then pi will cancel out. It will be 6 into 180. It's actually 30 degrees. Like this. Then next one, 7 pi over 3. 7 pi over 3, that's part E. 7 pi over 3. You multiply by 180 over pi, which is equals to pi will cancel out. 3 into 18 into 180 is 60. Then 60 by 7, it will be 420. Done. Right, let's move on to the next part. Next part is arc length, area of a sector, and also perimeter of a sector. How can you calculate those things? Right. Then let's start with arc length. Arc basically is part of the circumference of a circle. So to get the arc length, you get it right away from the circumference of a circle. So the circle, let me draw it. It's like this. I can mark these 2 points A and B. This one is the minor arc. Then on this side we have the major arc. Let's say minor arc AB. How can we calculate the length of that minor arc AB? So since we said we get that one from the circumference of a circle, which is the distance right around a circle. What is the formula for the circumference? Is 2 pi r, like this. So to get the arc length AB, what we do is we use the angle that will be subtended by this arc AB at the center of the circle. We can call it theta in this case. Yes, I have put theta, which means this one is the radius, this one will be the radius. Like that. So the proportion of this angle subtended by this sector is to the angles at this point. That is the angles in a circle, they add up to 360 degrees. So 360 in radians. Remember, these things basically you have to put to work out these angles in radians, not in degrees. So instead of using 360, we use what? 360 in radians is actually 2 pi. So it will be theta over 2 pi times 2 pi r. That's the arc length. Right, then if we can cancel out these things, let me cancel out the things. The 2 will cancel off, pi will cancel off, then you get arc length is equals to, it will be r theta or theta r, still is the same. Say theta r or r theta is still the same, but I just prefer to say r theta, like that. So that's the arc length. Right, moving on to the area of a sector. Sector is actually part of the area of a circle. That's called a sector. Like this. This one is the sector. This one, shaded sector. It's sector. This one is the minor sector. Minor. Then this one is the major one. Major sector. Like this. So sector is part of the area of a circle, which means to calculate the area of a sector, you just calculate from the area of a circle. How do you calculate the area of a circle? It's actually pi r squared. Then we use the proportion of the angle, let me call it theta here, subtended by this sector at the center of a circle. This will be radius. So as to the angles at a point. Angles at a point, this one, they add up to 360 degrees, or angles in a circle add up to 360 degrees, which is 2 pi in radians. So we say theta over 2 pi times area of a circle. Then the pi will cancel out. Then we'll be left with area of sector is equals to, so this one will be half r squared theta, or you can say r squared theta over 2, still is the same. I prefer half r squared theta. So that's how you calculate the area of a sector. Please take note of that. Then moving on to the perimeter of a sector. Perimeter of a sector. So let me break down this one, the sector here. With radius and an angle theta. Then we have an arc AB here. So the perimeter of a sector, it will be, let me write here. Perimeter, it will be equals to, right, so the first part we have radius, this radius plus this radius, so you say r plus r plus then arc length plus arc length, length of arc AB actually. So it will be 2r plus arc length is what? Arc length is r theta. So that's the formula for calculating the perimeter of a sector. So it's 2r plus r theta. That is the arc or the length of an arc. Done. Next item, area of a segment. Right, what is a segment? Segment, it will be like this. This one is called the segment. It's the minor segment. Then this one is the major segment. Right, so to get the area of this minor segment, then we can use the sector from this part, where the angle subtended will be theta and the radius will be r, like that. So how can we calculate the area of that segment? As you can see, the segment is made up of two different things here. We have a triangle and a sector, like this. So this one will be the segment, radius. Then Then we have our theta here. So to calculate the area of this segment, what do we say? We say area of the whole shape, which is a sector, minus area of the unshaded part, which is a triangle in this case. So segment area of segment, we say area of the sector, minus area of triangle, minus area of this triangle. So area of a sector is actually half r squared theta minus, then area of a triangle, in this case there's no height, right? Remember, it's what? Half AB sine theta. So it will be half AB, which is r times r, then sine theta. So it will be half r squared theta minus half r squared sine theta, like this. So you can just end there. But the most important thing is to know how to calculate. Cramming the formulas, yes, but it's not that all important. You have to know the origin. How can you get those things actually? That's what matters the most. So from this one, you can see in the books, it can be like half r squared, then theta minus sine theta is still the same as the formula to calculate the area of the segment. And note that our theta here in this case, it will be an angle in radians, not in degrees, in radians. Which means if you're using a calculator, you have to put it in RAD mode, not in DEG, not in degrees, but in radians mode. Right, these are the questions now. First question, as examples. The perimeter of a sector of a circle, center O is 16 centimeters. Given that the radius of the circle is 5 centimeters, find in radians the angle theta subtended at the center of this circle. The perimeter of a sector of a circle, center O is 16 degrees. So this one is a circle, and the perimeter of the sector, like this. So this one is r, this one is r, this one is theta. Then we have our arc length here. We can call it AB. So we are given the perimeter of a sector in this case as 16 degrees, and the center is O here. Then given that the radius is 5, okay, let me just replace radius with 5. So the radius here is 5 centimeters. Then find the angle subtended at the center. Very simple, very easy. What you just have to do is you find the area of a sector, the perimeter of a sector, then you equate to 16. You equate to 16. So perimeter of a sector is this one 5. Let me write it here. 5 plus 5 plus, that's radius plus radius. Was it like this? Radius plus radius, then plus arc length. Then arc length, we don't have arc length here. Given that the radius is 5, so you say plus arc length, which is r theta, then is equals to 16, like this. Then r is actually 5, so I was supposed to replace r with 5. Right, let me do it right down here. So it will be 5 theta is equals to 16. Then simplifying this one, we get 5 theta is equals to 16 minus 10. Then 5 theta is equals to 16 minus 10. 16 minus 10 is 6. So you get your theta is equals to, after dividing by 5 here, it will be 6 over 5 radians. Just like that. So that's the question. Next part. Next question, question number 2. It reads, the length of arc of a sector of a circle is 15 centimeters. So this arc length, please take note of that. How can you calculate arc length? You say r theta. So r theta is equals 15 degrees. 15 centimeters. 15 centimeters. That's the arc length. And the area of the sector of the circle is 75 square centimeters. Find in radians the angle subtended at the center. We want also the angle here, right? So we are forming equations here. The first part, we have formed an equation, r theta is equals 15, that's arc length. Then the other equation is formed from the area of the sector of the circle is 75. Area of the sector is half r squared theta is actually equal to 75 square centimeters. Then from this, we have two simultaneous equations. We can solve them simultaneously. This one, you can call this one equation 1, this one equation 2, right? Then using substitution, we want the angle, right? So we can say here, in equation 1, r is equals to, let's make r subject of formula. R is equals to 15 over theta. 15 over theta. Then this one you can call it equation 3. Then now we have to substitute this one in equation 2. Where there's r, you put 15 over theta. So you say half r squared, you say 15 over theta squared, then times theta is equals to 75, like this. It will be half, then 15 squared is actually 225. That's 15 squared, right? 15 squared is 225 over theta squared times theta is equals to 75, like this. Then you simplify theta squared and theta, you just be left with theta there. So it will be 225 over 2 theta is equals to 75. Right, let's simplify further. 225, we want theta here, so you can multiply by 2 theta. 2 theta here, so it will be 225 is equals to 75, or you can cross multiply times 2 theta. It will be 225 is equals to 75 by 2. What do we get? It's 150. 75 by 2 is 150. 150 theta, like this. Then you divide by 150 both sides. 150, then you get 225 over 150. Simplify that one. 225, you can use your calculator to simplify, right? 225 over 150. What do you get? You get 1.5 or 3 over 2. 3 over 2 or 1.5. So your theta will be 3 over 2 radians. Or you can say 1.5 radians. Done. Next question, question number 4. It reads, a chord PQ of a circle radius 5 centimeters subtends an angle of 2 radians at the center of the circle. Calculate the length, part A, the length of the major arc PQ. A chord PQ of a circle radius 5 centimeters. Let me sketch. It's actually very important to sketch. So we have a chord here, a chord PQ. Let me put it this way. Chord basically, let me put it this way. That's a chord. A chord is just a line from one point to another point of the circumference of a circle. Then a special type of a chord that divides the shape of the circle into 2 equal parts is actually called a diameter. It's a diameter. Right now we have our center here, center O. Then, so a chord PQ of a circle radius 5 centimeters. So this radius is 5 centimeters. Let me join this side also. This one is also 5 centimeters. Then subtends an angle of 2 radians. So this one is 2 rad at the center of the circle. Then calculate the length of the major arc PQ. Major arc is this one. So this point is P, this one is Q. So that's the major arc PQ. So we say area, the length of arc PQ arc is equals to r theta. Now we have to find the R. What is our R? It's 5. We have to find theta. What is theta? In this case, the angle that we are supposed to use is the angle subtended by the major arc at the center of the circle, which is this angle here. It will be 2 pi minus 2 radians, right? So it's 2 pi minus 2 radians. With angles at this point in radians is actually 2 pi. In degrees is 360 degrees. So it will be radius is 5 times 2 pi minus 2, which is equals to, you can remove the bracket, 10 pi minus 10. Why? So you can simplify this one using a calculator. So 10, then you can use your calculator from your pi from your calculator. 10 pi minus 10. If you can simplify that one, what will you get? 10 pi minus 10. So as a decimal, you get to 3 significant figures. You get 21.4. These are centimeters. So that's the length of the arc PQ, the major arc PQ. Take note of that. So that was part A. Then part B, the area enclosed by the chord PQ and the minor arc PQ. So the area now is this one, enclosed by the chord PQ and the minor arc PQ. So this is the area. It's actually the area of a segment. That's the one that you have to calculate in this case. Right. Let's calculate the area of this part. You say area of a segment, that's B. Or let me break it down. Let me remove this part. This one is PQ. Then this one is the area that you want to find of this segment. Radius 5 centimeters, 5 centimeters. Then the angle is 2 radians. 2 radians. Right, so the area of this segment, we say area of the sector, that is the worship, minus area of the unshaded part, which is a triangle. So it will be area of a sector. How do you calculate area of a sector? It's actually half r squared theta. So it's half r squared theta minus area of a triangle, half r squared sine theta, like this. So that's the area of the segment. That's the area of the segment of the area enclosed by PQ and the arc, chord PQ and arc PQ. So it will be half r squared theta. It will be half, our r radius is 5, so it will be times 5 squared. Theta is 2 radians minus half r squared is 5 squared times sine theta, sine 2 in radians. Make sure your calculator is actually in radians mode. Right, then after that you simplify 2, it will be 25 here. Let me write this one properly. So this one, it will be 25 minus this one, 25 over 2 sine 2. Right, let's simplify. You can use your calculator. You can say 25 minus 25 over 2, which is actually, you can say 12.5 sine 2, but make sure your calculator is supposed to be in radians mode, right? It's supposed to be in radians mode. So if we can put in radians, correct to 3 significant figures, it will be 13.6. These are square centimeters. These are square centimeters since it's area. Please take note of that. Then next question number 7. The diagram shows the cross section of a tunnel. The cross section is the shape of a major segment of a circle, and the point O is the center of the circle. The radius of the circle is 6 centimeters, and the size of the angle AOB is 2 radians. Size of the angle AOB is 2 radians. Calculate the perimeter of the cross section. Calculate the perimeter of the cross section. Right. I read again. The diagram shows the cross section of a tunnel. The cross section is the shape of a major segment of a circle, and the point O is the circle, is the center of the circle. In this case, we are given that the radius is 6 centimeters and our angle is actually 2 radians. 2 radians. So I want to calculate the perimeter of the cross section, which is the distance around this item. So from this point to this point, then plus this distance from this part to this part, AB. AB is a straight line, so it means we have to use some other method to solve this one, or to find the distance AB. Then the distance AB of the major segment or major arc is actually easy to find. It's actually easy to find, right? So how can you find that one? We just have, we know that the angle here is 2 radians, which means the angle on this side is actually 2 pi minus 2. That is the angle on this side. Now let's find the length of that major arc first. So the length of the major arc, that's the first part. Its length of an arc is what? It's r theta, which is equals to our angle, our radius is 6, then theta is 2 pi minus 2, like this. Then it will be 12 pi, if we can remove the brackets, minus 12. So that's these are centimeters. This one is the length of the major arc. Now we are left with the length of the line AB. How can we calculate the length of line AB? Right, that one, we can use the cosine rule now. We can use the cosine rule, or we can use what? The sine rule or the cosine rule. The sine rule, it means we have to find these angles first. That's how or when we can be able to apply the sine rule. But right away, let's just use the cosine rule. We want to find the length of AB. So length of AB is equals to, you say AB squared by cosine rule is equals to 6 squared plus 6 squared minus 2 times 6 times 6, then cos 2. Then it will be 6 by 6, 36. 36 plus 36 is 72 minus 2 times 6 times 6. 2 times 6 times 6, which is 2 times 36 is 72. Then cos 2. Right, so this will be AB squared is called this one. Then to calculate the length of AB, you put the square root. So you say AB is equals to square root of 72 minus 72 cos 2, which is equals to, you can punch in your calculator, square root of 72 minus 72 from your calculator, cos 2. Make sure your calculator is always in radians, right? Make sure your calculator is always in radians. Right, so in this case, I'm getting 10.097655 what? So to 3 significant figures, it will be 1, 2, 3. It will be 10.1 centimeters. Done. Then the length of the tunnel, that is the perimeter of the tunnel, it will be perimeter of or arc length AB major, then plus length of AB line. So which is 12 pi minus 12, 12 pi minus 12, 12 pi minus 12, then plus 10.1 centimeters. This one is that's the perimeter, the required perimeter. It will be equals to 12 pi minus 12. You can use a calculator. So it will be 12 pi minus 12 plus 10.1 plus 10.1. What will we get? 10.1. It will be 35.8 to 3 significant figures. 35.8 centimeters. Done. Right, next question. A sector, this one is question, I think, number 3. A sector OAB of a circle of radius A and center O, yes, angle AOB theta radians, given that the area of the sector AOB is twice the square of the length of arc AB. Find theta. These are weight problems. Please take note of that. The area of the sector OAB is twice the square of the length of the arc AB. Let's do this one. First, let me sketch my diagram here. Sector, or let me not put the circle, right? Let me just put it or draw it like as a sector. Let me just put a sector here. Right, so this sector, radius is A centimeters here, and center is O. A sector OAB, O, so it means this is supposed to be A, this is supposed to be B, this point B, this point A. Of radius A and center O, is angle AOB theta, which means this angle is actually theta radians, given that the area of the sector OAB, area of this sector OAB, which is half r squared theta, is equals to what? Is equals to twice. That's the area of the sector OAB is twice the square. Is twice the square of the length of arc AB. Arc length, which is r theta squared. Like this. Then they say find theta. Find theta. So this one is twice. It means 2 times the square of the arc length. 2 times r theta squared. Take note of that. Then let's simplify this one. It will be, you can multiply by 2 everything, right? To get rid of these 2. Or let's first remove the bracket. Is equals to 2. You share the power, theta squared. So it's r squared theta squared. Then let's divide by, we can divide by r squared. Yes, both sides by r squared. So it will be half theta is equals to 2 theta squared. Then after that, you divide by theta. You can divide by theta here. So if you can divide by theta, both sides, what do you get? You get half is equals to 2 theta. Yes. Then next, we have to remove these 2 on the side where there is theta, which means we divide by 2 both sides. So it will be half divided by 2 is equals to 2 theta over 2. These 2 and 2 will cancel out. So we'll be left with what? We'll be left with half divided by 2 is half times 1 over 2 is equals to theta. So you get theta is equals to 1 over 4 radians. So that will be the value of our theta. Done. Right, next part. Next question, supposed to be 4 or 5. The diagram shows a sector of a circle with center O and radius R. The length of the arc is equal to half the perimeter of the sector. Find the area of the sector in terms of R. I read again. As you can see on the screen, the diagram shows a sector of a circle. Oh, there's a part missing here. Oh, the diagram is here. Okay. So this diagram down here it shows the diagram shows a sector of a circle with center O and radius R. The length of the arc is equal to half the perimeter of the sector. Find the area of the sector in terms of R. So the length of the arc is twice length of the arc, which is R theta, is equals to twice. The length of the arc is equal to half, so it's equals to half the perimeter of the sector. Perimeter of the sector, remember, it's a radius plus arc length, like this. So the diagram is here. Let me move down here. This is the diagram. It's here. So they say, oh, this is a different diagram. Then the length of the arc is equal to half the perimeter of the sector. Find the area of the sector in terms of R. But still, even if there's no diagram, the information given here is actually enough for you to be able to work out this question. So the length of the arc is equal to half the perimeter of the sector. Half the perimeter of the sector, which is like this. So the diagram, I assume, is like this. Sector of a circle, radius is R and O is the center. Then the arc length, which is arc length of this one, AB, is half the perimeter of the sector. So it will be like this. Now let's simplify and find the area of the sector in terms of R. Right, simplifying this one, you can start by simplifying inside the brackets. Half, then 2R plus R theta, like this. Then next thing, you remove the 2, you multiply or you cross multiply by 2, it will be 2R theta is equals to 2R plus R theta. Then from this one, you can be able to collect like terms, simplify. Like you can put this R theta on this side, since they are like terms, 2R theta minus R theta is equals to 2R. Then from this one, you can get R theta is equals to 2R, because they are like terms. Then from this one, you can get your theta is equals to, divide by 2. Divide by R, you get your theta is equals to 2. So theta is 2 radians. Then they say, find the area of the sector in terms of R. Which means the area of the sector, how do you calculate area of a sector? Area is equals to half R squared theta, which is equals to half radius is R squared times theta, which is 2. You just take this one, which is equals to 2 and 2 cancel out. So you get the area is R squared square centimeters, like this. So that's the area of the sector in terms of R. Done. Right. Then please just follow up the procedures, what I was doing, the IG was doing. Then after watching this video, please don't forget to like and subscribe to the video, and also share this nice powerful video, right? I hope you enjoy. Then for more videos, they are available on my YouTube channel at Mangeya. You can enjoy.